Today is the last part of chapter 6, uh, which is pages between 167 to 170. First of all, I need to explain you about the concentration of solution. The main topic is mole and solution chemistry, but specifically we are focusing for concentration. There is two way to measure a solute. A solute is the one we dissolve in a solvent. In like as a common solvent is water, water or hydrochloride or any other liquid form as our solvent. We use solute, okay, to solve it, to dissolve inside, like salt, like sugar, or any other things. So there is two way that we can measure solute, okay, by number, which is moles, and moles can be considered as a number of moles. And the another one is mass, which the unit is grams. Okay, we use grams for measuring mass of the solute. By number, um, the concentration is molar concentration. The type of concentration is molar concentration, and it can be obtained from uh, division of moles of solute to volume of solution. Uh, Volume can be uh, cubic decimeter, and the moles of solute of course is mole. And so the unit of uh, the products, I mean the unit of the molar concentration is mole per cubic decimeter. For the mass, which is based on gram, is mass concentration. We can measure for mass concentration, and can be taken from division of mass of solute on a volume of solution. Volume of solution is a whole volume of your final solution after dissolving. After dissolving is the final one, is a volume of the solution. Okay, and it can be say uh, cubic decimeter, and mole of solute is gram. Okay, so look at the next slide. This shows you an overview of a concentration. What is the concentration? Here, if we have 1 mole of copper sulfate, okay, 1 mole, if we put in one, you can see the measurements, okay, the degree are here. And okay, if we put 1 mole to 1 cubic decimeter of solution, you will have 1 divided to 1. Okay, the answer is 1 mole per decimeter. If you use the same mole of copper sulfate as solute, and it dissolved to 2 the cubic decimeter, like this one, okay, is higher, so your concentration would be half. Okay, is 1 divided to 2 is half. Okay, 0.5 mole per decimeter. So if our solute is 2 mole, like 2 mole copper sulfate, and it dissolved to 2 1 cubic decimeter, here we have a very concentrated solution. But this one very dilute diluted solution. This is very concentrated solution because you have 2 mole solute to 1 cubic decimeter of solution. So the answer, the concentration is 2 mole per cubic decimeter. And final, if we have the same amount of copper sulfate, 2 and 2 uh, solution, it would be 1. Okay, like the first one. Okay, the first one is concentration is 1 to 1, and the first one is the also concentration is 1, but the volume is much more, but concentration is same. Okay, and next one, here we are going to learn how to calculate the concentration through these two main equation. We can find number of mole in solution. We have two important equation. From the first or second, we can get number of moles in solution. At the first one is equal with molar concentration times to volume of solution, which is cubic decimeter. And the second one, all are same, only in molar concentration can be changed to another form, like concentration divide to 100 1000. Okay, but the volume solution is based on cubic centimeter. Because of this change, cubic decimeter to cubic centimeter, we need to use 1000 here to make it equal. But it's equal, it's the same view, same equation. You can get number of, you need to have number of moles and volume, something those terms. And uh, to better understanding, we need to practice on questions. Okay, one question for this concept is here, and it asks us uh, calculate the concentration of a solution of sodium hydroxide, NaOH, that contains 10 gram of NaOH in a final volume of 250 cubic centimeter. Okay, totally there are two steps. First step, find out how many moles. We need to find how many moles based on what we have, based on what we can get from question. The question gave us a formula, a molecular formula of sodium hydroxide. Okay, what we can get from sodium hydroxide? First, we can calculate the relative formula of mass, the mass from the periodic table. And sodium has 23 molar mass, and oxygen 16 from periodic table, and 1 from hydrogen. The total is 14. Okay, and we learned at the earlier of the chapter, reminding here again, number of moles equal mass divided to molar mass. Here we have a molar mass 40, we can calculate by ourselves from the periodic table. This mass can be obtained from the question. The question asks you how much mass, how much gram we have. Okay, 10 gram of this compound is a mass, and molar mass the thing is we can calculate from the periodic table. Finally, you can get how many moles we have. Okay, how many moles? Here the answer is 0.25 mole. Okay, so now we have the number of moles. If we look back to this slide, okay, and here I can show you the question asks you cubic centimeter. Okay, be careful for these units. Cubic centimeters, that means you need to use this equation, the second one, because this equation is based on cubic centimeter, not cubic decimeter. So you need to use the number of moles in solution that has already been calculated, and concentration 1000 that is available, and volume of solution. So we use this equation, the second one, number of moles. Here we have calculated, we put here, and 1000. Okay, it's clear and no need to calculate, of course. And concentration is the thing we are looking for. If you read carefully the question, calculate the concentration. Okay, question asked you calculate the concentration. So we just leave the concentration here, and the volume is 250 cubic centimeter as the question gave us. So this is finally simple mathematical equation, and you need to calculate for the concentration. And 250 has a direct times with concentration, and 0.25 can times to 1000, and can be here, and then you can continue. Okay, another example, as your book has explained about acid-base titration. You need to just have a review again and read the text, but I skip that explanation and directly move to the example. Titration is very similar and very suitable for this concept to find concentration of our products. Okay, because if you remember from the acid-base titration, as I explained in face-to-face class, finally you will get a neutralized solution, which acid or base finally will be neutralized, and the solution will be neutralized. Then, but from this chapter you can calculate the final concentration, how much concentration of acid or base will be obtained. Okay, look at this flow chart is very important, and I'm showing you the stage of each flow chart by this example. The question asks you a solution of hydrochloric acid is titrated against a standard sodium hydroxide solution. Okay, hydrochloric acid, of course, is an acid, and sodium hydroxide is a base. Okay, we are using titration. We are going to mix together slowly, step by step. Then what happened? It is found that 20 cubic centimeter. Again, if you remember the last two equation, cubic centimeter is the second one. Okay, after acid neutralized, 25 cubic centimeter of 0.10 mole per decimeter cubic decimeter sodium hydroxide solution. What is the concentration of hydrochloric acid solution. That means the final concentration. We have um, um, yeah, we have a flow chart here is very important, and we need to use every information that we can get from our reactants and from the question that give us as a key to find the moles of reactants. From the mass of reactants, we can get mole of reactants. From the volume of the gases, if you refer back to our last uh, session, we studied about volume of gas. From the volume of the gas, also we can get mole of reactants, and concentration and volume. We can get mole of the reactants. Then here we need use a chemical reaction. Okay, from the chemical reaction, if we write the chemical reaction, we can use a ratio from how many mole of the reactants we can get how many mole of products. Then from the mole of products, we can take mass of products, concentration, or volume of products. Okay, from this question, step 1, information from the question: how many moles of alkali are in a flask or in our dish, laboratory dish? The number of mole of uh, this one hydroxide, sodium hydroxide. The number of mole can be taken from concentration divided to 1000 and volume, because we have volume. Okay, and we have the concentration here, we have the volume also. Then we can easily get the number of moles, because every terms every term is prepared, is available. Okay, then after that we move to the second step. Here we need to use a ratio by a chemical reaction, as I explained before. Use chemical equation: how many moles of acid are used. We used 1 mole acid, okay, and we used 1 mole hydroxide, sodium hydroxide, okay. Then 1 mole um, base can neutralize 1 mole acid. So if we have 2.5 times 10 power minus 3 mole of uh, our base, so we need to use the same amount of mole for acid, okay, because and previous slide we get this amount, this number of moles, okay. We get 2.5 times 10 power minus 3. This is the number of the moles that we can get. Not here. Yeah, we can get, okay. So if we have 1 mole acid to 1 mole base to run a neutralization uh, chemical reaction, so for this number of moles that we obtained the previous one, we need to use the same number also, okay. The next one, we move to the product. Use titration value. What is the concentration of acid from the mole of acid that is it has same ratio with the base. We use same number to find a concentration. Here again we use the same equation, but This time number of moles is clear. We have the number of moles from using the ratio, and we put it here. We are looking for concentration of acid. 1000 is available, and volume also is available from the question. Okay, 20. So here the last part is the concentration that we are looking for. Then we can run a calculation and to find how much concentration we can get from acid, because we need to use the same ratio of acid and base to have a neutralization or acid base titration is same meaning, to have this reaction. Okay, and this is very important. Try to keep in your mind for this flowchart. And here I put one question for you. Please study and read carefully this question, and look at the chemical reaction and try to find the answer. And now chapter 6 has been finished, and we need to wait for the final exam of this semester and this year of study. And after that, yeah, we need to wait for any announcement, and we can decide what we can do. Take care and stay safe at home. Hope everything is going smoothly for you, and that's all. Thank you so much.